In this course, you will predominantly use keyboard to send data input to your programs. You will learn how to feed data from files later on in the course, but let us stick with the keyboard for now. Let's see what it takes to write a program that does this. Accepting radius value as an input from the user, evaluating the area of the circle, and then displaying it. I'm going to quickly run the same program again with a different input and see how it works. If you observe closely, I managed to display the newly entered radius and the corresponding output up to 1 decimal point precision. We will explore all the concepts involved in here one by one. First, the concept of variables. You can think of a variable as a flexible box that is capable of storing a small number like this to a huge paragraph like this one. In reality, the variable is simply a name that is mapped to the data you're assigning it with. The equal to sign is the assignment operator. It assigns the data to the variable. A variable to be assigned should always be on the left. A variable can be assigned as well as reassigned. Int, float, and string are three predominant data types we'll be using in the first half of the course. Whenever you assign a variable with numeric data without using a decimal, it will be stored in the memory as an integer data type. If you assign a number that has a decimal, it will be stored as a floating point data type. You might ask, why do we need two different numeric data types here? Well, mathematical operations on integer data can be done pretty fast by computers, but integer data type cannot store large values. On the other hand, floating point data uses scientific notation which is capable of storing pretty large numbers. But that comes with a cost of lower performance. Floating point arithmetic is an interesting area. If you'd like to explore more, check it out. You have seen strings in action already. You can use single or double quotes around data you like to input, and Python interprets that as a string. Now let's talk about entering input from a keyboard. To do that, we use input function. The input function consists of a prompt that will be displayed to the user when it is executed. Make sure your prompt is a string. To capture the data entered from keyboard, you use a variable. By default, input function captures the keyboard data as a string. This will get us into trouble if we are trying to perform arithmetic operations on it. Hence, we convert the user input directly into an integer or a floating point type by writing the input statement this way. Let me take you to the area of circle program I demonstrated earlier. You can see that I assigned the variable radius with user input value that is converted to an integer. Cool. Now let's talk about processing. We shall limit our discussion in this session to performing calculations. Here is the list of Python math operators. I'll do a quick demonstration of each of these operators now. Let's look at addition, subtraction, and multiplication, which operate in the same way. So adding two integers will give you an integer. Adding a decimal point in any of this process is going to give you an output, which is a floating point number. So you can see that pattern repeating for all the three operators. Cool. Now let's talk about division. When two numbers are divided, irrespective of what data type they are, the output is always going to be a floating point number. If you want the output to be an integer, you'll have to perform integer division, which is double slash. Here is the tricky part. If you perform integer division of 5 by 2, then the answer would be 2. Python always rounds it off to the lower bound. So if you do -5 divided by 2, the integer division, you'll have the answer -3. Because for -2.5, the lower bound is -3. To find remainder, you'll use the percentage sign. Okay, so 5% of 2 is basically asking Python, what would be the remainder if I divide 5 by 2? Similarly, 8 by 3 would give me a remainder of 2. And yeah, so that would give you a floating point number. Finally, the exponent operator. You use a double star to perform exponentiation in Python. So phi cube is, phi double star of 3. If you want to find out what phi to the power 4 is, you would write it that way. Okay, now pay close attention to what I'm going to discuss right now. While writing statements that use complex mathematical expressions, you have to keep operator precedence on your mind. Take this example. What do you think the output will be? Will it be 12 plus 6, that is 18, divided by 3, that equals to 6? Probably not. So the correct answer for this is 14. To understand this, you might want to check the operator precedence in Python. Here is the snapshot of operator precedence in Python. Whenever you see an exponentiation in your statement, evaluate that first, and then move on to multiplication, division, or remainder. All of these have the same priority, and then the least priority is given to addition and subtraction. Alright, so keeping operator precedence in mind, let's evaluate this. So I'm going to do exponentiation first. 3 squared is 9, and then multiplication. 2 multiplied by 9 is 18. 18 plus 5 is 23. Perfect. What if you have an expression where all the operators in it have the same precedence? Like I have multiplication, division, and remainder operators here. All of them have the same priority. So in that case, you would evaluate it from left to right. So 5 eighths are 40. 40 divided by 4 is 10, and then 10% 3 will be 1. Oftentimes, you'll have to convert formulas into code in Python. If you have written a code like this for the formula, then you're making a mistake. Take a close look at that. You see that division will take the precedence, and then x divided by 1 will be x minus x will be 0, and you'll end up with an answer 1. That's why you might want to use parentheses. So parentheses will always come for your rescue when you're dealing with formulas. Okay, so always use parentheses when dealing with formulas. So that's the right answer. We shall discuss output and its formatting in a separate lecture, but for now I'll briefly explain the output display statement I had in the area of circle program. After taking the user input for radius and computing the area, I have a print statement that has two variables in it, radius and area. If you look at area, I have did some kind of formatting where I've written 0.1f. It means that I want my result to be of 1 decimal precision. More on this in the next lecture.